Hello, scholars. Welcome to video 2. We're in Unit 5. Yesterday we talked about energy in general. Today we're talking about kinetic energy, a type of energy. Tomorrow we'll do potential energy. So let's get into kinetic energy. Kinetic energy, as you saw yesterday, is the energy of motion. All right? But as physicists, as scientists, we like to be able to quantify these values. When we describe the concept, we want to be able to give a value and say, how much kinetic energy does an object have? So we want to know how to calculate that, all right? And as scientists were investigating this, they learned that the amount of kinetic energy an object has depends on two factors: its mass and its speed. And through experiments, they determined that the amount of kinetic energy an object possesses is equal to one half times the object's mass times the object's velocity squared. Okay. If you don't like squares, that's just the same thing as saying 1/2 mass times velocity, because velocity squared is velocity times velocity. Cool? Alright, so just in general, before I get into the numbers, notice that an object has to have mass to have kinetic energy. If it doesn't have mass, then anything, no matter how fast it's going, anything times 0 is going to be 0 joules. Notice, units for kinetic energy are measured in joules, the same unit as we use for work. Okay. Also, that object, in order to have kinetic energy, must have a velocity. It must be moving. All right? So even if an object has mass, but it's not moving, notice 0 meters per second, anything times 0 is 0. So no mass or no velocity, that means no kinetic energy. All right, let's see how to use this equation. Look at this row right here. If I have an object with a 1 kilogram mass and a velocity of 10 meters a second, then what I do is I say 1/2 times 1 times 10 squared. 10 squared is 100. Times 1 is 100, times 1/2 is 50, and I get 50 joules. Cool? Try it on your own. I want you to write down the equation, substitute in, include your units, and see if you get the same answer. Make sure I'm right. I'm not always right. Right? Right. Okay. So, next, what's the relationship between these variables? You know me. I like to know relationships. I'm going to ask you about relationships on the test. So let's talk about relationships. All right. What's the relationship between kinetic energy and mass in this equation? All right. If I double my mass, so I go from 1 kilogram to 2 kilograms, see right there? Okay. But my velocity stays the same, both 10 meters a second. What happens to my kinetic energy? It doubles, goes from 50 to 100. So when I double my mass, I also double my kinetic energy if velocity stays the same. This means that mass goes up, kinetic energy goes up, they are directly proportional. Mass goes down, kinetic energy goes down, they are directly proportional. Whatever happens to one happens to the other by the same factor. Is this the same relationship for velocity? That square on the velocity changes things a little bit. Take a look here. If you double velocity, so let's look at lines 3 and 5 here. So I have a 1 kilogram object and a 1 kilogram object. I'm keeping mass the same. But I'm going to take my velocity and double it from 10 meters a second to 20 meters a second. What happens to my kinetic energy? I go from 50 joules to 200 joules. Did I double it? No, I quadrupled it. Okay, so this is a little different. I increased proportional to the square of the velocity. So when I double velocity, I quadruple my kinetic energy. So I go from twice as fast with my velocity to 4 times the amount of kinetic energy. Okay? Do these calculations yourself on your sheet. Double check that I'm right. You know I'm not always right. Take a look in the book, pages 447 to 448. Complete your worksheet. I'll see you in class.